Hello everyone, thank you for watching my video today on graphing rational functions. Before we get started here, there's an opener problem on the parent rational function. So what I'd like you to do is to complete the table and graph this by hand. You can always use your graphing calculator to check the graph. When you're done, you can come back and check your answers on this video. Pause the video now and try the opener. Here is what our table and our graph should look like. You can pause the video here if you need to watch this further. But now let's take a look at some key features of this graph that we're going to talk a lot about today. So starting with our first one, our vertical asymptote. A vertical asymptote is a vertical line that the graph cannot touch. Okay, it cannot cross or bounce off that vertical asymptote. So our vertical asymptote is this vertical line right here. The equation of that would be x equals 0. A horizontal asymptote is another line that a graph can touch a horizontal asymptote. Okay, it usually doesn't, but it can happen. Okay, in this case it will not, but our horizontal asymptote is this line right there of y equals 0. X-intercepts is we would set y equal to 0 and solve, and there's no solution to that, so there'll be none. Y-intercept, you would do f of 0, and that's undefined, so there's no y-intercept either. End behavior for rational functions is a little different than polynomials, where it's not always going to be positive, negative, infinity. In fact, if there's a horizontal asymptote, that's where our end behavior is going to go. So as x goes to negative infinity, y is going to go to 0. And as x goes to positive infinity, y is going to go to 0. And you can see that on the graph there. It's following that line to the left and to the right, the graph of the line y equals 0. All right, so this next slide is a summary in graphing rational functions. We're going to do this for a couple days here, but this is a big summary of it all, okay? The first step you want to do is factor that numerator and denominator completely, okay? And then 2 and 3 kind of go together. Any zeros in the denominator that are not zeros in the numerator are called vertical asymptotes. Any zeros in the both numerator and denominator are called wholes. We'll talk about how to find those later. Then we'll find a horizontal asymptote or an oblique asymptote. We're just going to do horizontal today. Oblique will come later, but here's how you know if it's horizontal or oblique. If the denominator's degree is higher, so if the denominator's degree is higher, we call it bottom heavy, and the horizontal asymptote is y equals 0. If the numerator and denominator's degrees are the same, we say it's leading coefficient over leading coefficient, and you reduce that fraction. If the denominator is 1 less than the numerator, it's going to be an oblique asymptote, and we do that by long division. We'll talk about that next. And then if the numerator is 2 or more less than the numerator, then there's neither oblique nor horizontal. Then we find x-intercepts like you've always been finding x-intercepts, right? Set your numerator equal to 0 and solve. Find your y-intercept by letting x equal 0 and evaluate. And then you find as many points as you need and then draw your graph. All right. So that being said, let's jump right in and look at a couple of these. Here's our first one. We're going to graph this rational function here. As the last slide told me, the first thing I'm going to do is I'm going to go ahead and factor the numerator and the denominator as much as I possibly can. Keep going here. And we can actually cancel the x plus 1s, leaving us with this. All right, so vertical asymptotes come from the denominator, where it's a 0 in the denominator, but not in the numerator. Okay, so that would be when x is 2. How do I know that? Look right here, when x is 2. The whole would be a 0 in the top and the bottom. So that would be at negative 1. Negative 1 comma what? Well, that's what we got to figure out. When we're going to put negative 1 in, we don't want to put it back into the original function or the simplified versions of it. We want to put it into the factored and canceled version over here. Otherwise, you're going to get 0, which is not the answer. Or you're going to get 0 over 0, which is not an answer. So we put negative 1 into this equation over here, and we get 4 times negative 2 divided by negative 3. That'd be negative 8 over negative 3, which is 8/3. I'm going to place that hole on the graph, negative 1 comma 8/3, be right about there. I'm going to make it a hole, an open circle. Horizontal asymptote. All right, so this one we would say is leading coefficient over leading coefficient because the degrees match. So it's 4 over 1. So it's 4. So our horizontal asymptote is the line y equals 4. We'll draw that in a second. X-intercepts, we'll set the numerator equal to 0, the simplified numerator. So this equal to 0. All right, we get 4 times x minus 1 equals 0. That will happen at 1. So 1 comma 0. Put that point in the graph here. Y-intercept, you put 0 in for x. You can put that into any of these forms. But basically, you get negative 4 over negative 2, which is 2. So 0, 2. And behavior. So that's going to be your horizontal asymptote here. As x approaches negative infinity, y approaches 4. As x approaches positive infinity, y approaches 4. You could also wait until you actually graph it to do that end behavior. Sometimes it might be easier to do that. That's up to you. All right, so first, let's plot our points that we have. We got that already, that's done. Now let's plot our asymptotes. So I like to make my asymptotes, well, you have to make your asymptotes dashed lines here. So I would like to make them also a little thicker so we can actually see them on the graph. So there's that one. X equals 2. And then we have a horizontal one. At y equals 4. And make sure it gets on y equals 4. There we go. All right, and then we're going to draw as many graphs as we need to. And this one should have 2 graphs. How do I know? Basically, every time a vertical asymptote is drawn, it'll have another graph. So there's only one vertical asymptote. That means we'll have 2 graphs. The first part, we got that pretty much set up for us. Just follow the asymptotes left and down. Skip the hole. And then for the second part, we'll need a point to the right of 2. So pick 3 or 4 or 5, doesn't matter. How about 4? You can put that back into the original or to any of the simplified versions, but might as well use the simplified version if we can. So 4 times 3 over 2, which is 12 over 2, which is 6, so 4 comma 6. And follow the asymptotes up and right. And there's our rational graph. Second one, again, I'm going to start here by factoring and if you can cancel, then go ahead and cancel. So the vertical asymptotes come from the denominator, the simplified denominator, so that'd be x equals 1. The whole is what we canceled earlier, so that's negative 2 comma. Put negative 2 back in the simplified version, you get negative 5 over negative 3, 5/3. The horizontal asymptote, again, these match again, right? So it's going to be 1 over 1, which is, of course, just 1. So y equals 1. Our x-intercept, set the numerator equal to 0, x minus 3 equals 0. So 3 comma 0. Y-intercept, put 0 in for x. You get negative 6 over negative 2, which is 3, so 0, 3. And our end behavior is going to go towards the horizontal asymptote. Okay, so let's go ahead and graph this. I'm just going to go back up here and steal my asymptotes from before. All right, and let's move one to x equals 1. And move the other one to y equals 1. And let's plot some points. So negative 2, 5/3. Negative 2, comma 5/3. 3, comma 0. And 0, comma 3. And really, that should be enough information for us to graph this. Follow the asymptotes here. Follow the asymptotes here. And there's our graph. Okay, at this point, I would encourage you to pause this video. There's 2 problems left. You can try those 2 on your own and come back and check your answers. Pause the video at this point and give them a shot. All right, here is the answer to this one. Pause this video for as long as you need on this slide here. And the last one. All right, thank you for watching my video today. I appreciate it. I hope to see you again real soon.